what we're going to do is we're going to take the next step on our little jaunt here through other bases and systems of numeration. We are going to do the 4 basic operations in other bases. Again, told you the original premise for this class was to help train teachers. And so the value in this, if you do plan to be a teacher, the value of this is you now have to intentionally think through how to add things because we're in other bases, and it helps you now be able to explain it to somebody learning how to add using place values in base 10. Okay, so that's the principle here, and that's why we employ it. So here we go. I'm going to start with we're going to start with addition as our first operation. So here goes. We are going to add 3, 4 base 5 plus 2, 3 base 5. Now, before I get going, here's the question I want you to help me with. We are in base 5. Okay, so we have to think, I know it's difficult and we're going to have to be real intentional. We have to think in terms of groups of 5, not in terms of groups of 10 like we think presently. So here we go. When I add 4 and 3, what do we get? 7, but I'm not going to write 7 down because 7 is not a number in base 5. So here we go. So I'm just going to come over here on my scratch work for the first couple, and you're going to help me think this through. 4 plus 3 is 7. If I'm thinking base 5, if I'm thinking in groups of 5, how many full groups of 5 can I make out of 7 of something? 1. Okay, so I'm just going to write like I was writing an expanded notation. We've got 1 full group of 5, and then how many is going to be left over? 2. Okay, so here goes. So 4 plus 3 is 7. That is 2 left over and 1 full group of 5. So I'm going to carry the 1. So while I have to think about it a lot more intentionally, it's the same process we employ when we add things in base 10. You know, when you add 8 and 7 and you get 15, that 15 means you have 1 full group of 10 and 5 left over. We carry the 1. Okay, so same thing here. So now I'm going to do it again. I've got 1 and 3 is 4, plus 2 is 6. So let me come over here. 6 is how many full groups of 5 can I make out of 6? Okay, 1 full group of 5 again, and this time I have 1 left over. So it's 1, 1. So I have 1 full group of 5 and 1 left over, and I'm done. There's my addition base 5. Now you can see we got a whole bunch of examples here. So you're going to get a lot of chances to practice this. So I would like you to do exercise 1. Notice you're adding 5, 3 base 7 to 3, 6 base 7. All right, so for this problem, we have to put our base 7 caps on. So again, remember, I'm looking for full groups of 7 this time. So when I add 3 and 6, we would call 3 plus 6 what? 9. Okay, so I need to now convert the number 9 that I know into base 7. So how many full groups of 7 is the number 9? It's 1 full group of 7 plus how many left over? 2. Okay, so here we go. It's 1 full group of 7, so I'm going to carry the 1, and then it's 2 left over. I'm going to do the same thing in the next column. 1 and 5 is 6, plus 3 is 9 again. And now I don't have any other columns, so that's going to be 1 full group of 7 and 2 left over. Put a little base 7 there on the end, so anyone reading this knows that I've done that calculation in base 7. I know it's a little tricky the first few. Any input you got for me? We doing okay? All right, then go ahead down example 2. Okay, we're just going to keep doing the same thing. So down there, add 2, 1, 2, 2 base 3 plus 1, 2, 2, 0 base 3. All right, so here we go. This one's base 3, so we're thinking in full groups of 3. So let's give it a try. So the first one, 2 plus 0. 2 plus 0 is 2. Do I have enough for a full group of 3 there? Nope. So I'm just going to write a 2 right there. Now I'm going to go to the next column. 2 plus 2 is 4. And at some point, you might get decent enough at this that you don't need to write down the scrap work, and that's totally fine. So I'm just going to come over to the edge of my page. 4. How many full groups of 3 is the number 4? It's one full group of 3 and then one left over. So one full group of 3 and then one left over. The next column is 1 plus 1 is 2 plus 2 more is 4. So again, that's one full group of 3 and one left over. And then one more time, I've got one more column here. 1 plus 2 is 3 plus 1 more is 4. So again, that's one full group of 3 and one left over. And that whole calculation has been done base 3. So I'll put a little subscript there on the end just so that I know that it's base 3. Questions, comments, concerns about that problem? Well, then do the next one, base 5. All right, on this problem, we're thinking full groups of 5. So here we go. So the first column, my units, 4 plus 1 is 5. So again, just going over to the side, 5 is, how many full groups of 5 is that? 1. And then how many left over this time? Nothing left over. Great. So that means it's one full group of 5. So I carry the 1 and it is 0 left over, 0 units. The next column, 1 plus 1 plus 1 is 3. That's not enough for a full group of 5. So I'm just going to write a 3 right there. The next one, 2 plus 0 is 2. Again, not enough for a full group of 5. So 2. And then the final column, the one that's on the left, is 3 plus 2. Again, that's 5, which we saw. 5 is one full group of 5 and 0 left over. So I have 1, 0, 2, 3, 0, base 5. Right, a little base 5 there. Anything that tripped you up there? Anything you need to get further clarification on? We've got one more addition problem. Then we're going to move on to subtraction. We're just going to go through the 4 basic operations today. All right, well, with that, go ahead and do exercise 3. And let's just remember, I know it's been a long weekend, in base 12, the symbol A represents what in our base 10 mind is what? 10. And the symbol B is the numeral for what? 11. Great. All right, so I'm in base 12. So again, we've got to train our mind to think full groups of 12 here. So my first column, my units, I've got 2 plus b. That's 2 plus 11. That's what we would call 13. So now I got to convert 13 into base 12. Well, 13 is how many full groups of 12? It's one full group of 12 and then one left over. So one full group of 12, I carry the 1 and then 1 left over. Okay, and now we are off and running. The next column is 1 and 3 is 4. 4 plus 6, that is 10. That's not a full group of 12. So how do I represent 10 in this problem? The numeral A. Then in the next column, I have A, which again represents 10 plus 7. That's 17. So 17, how many full groups of 12 is 17? It's one full group of 12. How many are left over this time? 5. So again, one full group of 12, I carry the 1, and then the 5 left over, I just put a 5 right there. And then my last column, the one that's furthest on the left, 1 and 9 is 10. 10 plus 1 is 11. That's not a full group of 12. So how do I represent that? What numeral? A B. There you go, for sure. So that is B5A1. And there we go. If we lived in a base 12 universe, we would have appropriate names for the B and the A, and it'd be all fun. But we are just adapting. Okay, that's addition. So far so good. All right. Well, then next one, what we're going to do next is subtraction. And before we do one of the examples there, I'm just going to come over to the side. And what we're going to do is we're going to remind ourselves about the process of subtraction. So write down this problem, 481 minus 265. Okay, this is just plain old base 10 subtraction, just to remind ourselves, because if you're like me, it's probably been a while since you've subtracted not using a calculator. And I want to just remind ourselves of the process. So I look at my units column. What's the problem here when I go to subtract in my units column on this one? I don't have enough, right? I start off with 1, I got to subtract 5 from that. I don't have enough. So what did your elementary school teacher tell you that you needed to do at this point? You needed to borrow. So we look over to the 8, and the 8's like, oh, hey, I got something I can lend you. And so what does the 8 become when I borrow? 7. I've borrowed a group of 10. I've taken it away. And now I come over. I've got that full group of 10 that I just borrowed from the 8. And I come over here. And when I add that full group of 10, what does this column right here become? It becomes 11. You add that group of 10 here, and it becomes 11. And so now I can subtract 11 minus 5. 11 minus 5 is 6. 7 minus 6 is 1. 4 minus 2 is 2. And I get 216. Okay. Does that make sense? Everybody got that clear in your brain? So the only difference now with subtraction, that we're going to do is instead of base 10, we're going to be on other bases. So we have to just remember what the full group that we're borrowing. So for instance, let's do this. Example 3. So example 3 says I've got 401 and I want to subtract 265 from this. Okay, so here, oh, I'm sorry, this is also base 10 because that's why I made up the other examples. I have one more thing I want to cover here, and then we'll go and we'll do a different base. So example 3 is also base 10 because there's one other thing I want to remind you of for subtraction. So it's the same thing here. 1 minus 5, I don't have enough, so I got to borrow. But now what's the problem when the 1 goes to its neighbor to borrow? What's the problem here in the middle? It doesn't have anything to lend, right? So we got to go all the way over. And so this time the 4 becomes a 3. So we have that full group of 10 now, and we go to the middle. So the middle, the 0 becomes a what? Becomes 10, yes. But then maybe your elementary school teacher was like mine, and my elementary school teacher just told us not even to write the 10 there. I wrote it down to be thorough, but we're just borrowing anyway. So what does that middle now become because I'm borrowing? Becomes 9. And again, I've got a full group of 10. And that full group of 10 goes over here to the end, and that 1 becomes 11, just like it did previously. So 11 minus 5, that becomes 6. 9 minus 6 is 3. 3 minus 2 is 1. And we end up with 136. So now at long last, we can do this with another base. I'm going to do with you example 4 right there. I've got 3032 base 5 and 1004 base 5. So let's see how it goes. So on my units, 2 minus 4. Do I have enough to do that subtraction? No, so I have to borrow. Okay, this is a base 5 problem, so just keep that in mind. So I'm going to go over to the 3, and the 3 says, yeah, I can lend you something, so that 3 is going to become a 2. No difference to what we did before. But now what have I borrowed? I've borrowed a full group of 5. So when I come over here to the 2, what does the 2 become now? Becomes 7. Well, for us, that's how we're kind of cheating a little bit. We're using our own notation because it would just be too hard to say. Like if you really were a base 5 person, okay, if you grew up somewhere that used base 5, you would write 1, 2 here, just like we do. You would understand that to be one full group of 5 and 2 more, but that's too much for our brains to adapt to all at once as we're learning this. So we're just going to write a 7 there. Okay, and think about it like we would. So now 7 minus 4, that's 3. 2 minus 0, that's 2. 0 minus 0 stays 0. And then finally, the leftmost one, 3 minus 1 is 2. So I get 2023 base 5. All right, so if you feel all right about that, I know subtraction is a little more tricky than addition, so trying to take my time going through this. So what I would like you to do, please, is exercise 4, give it your best shot. Subtracting those. All right, so this is base 6, just keep that in mind. So here we go. The first column, my units, 2 minus 5. I don't have enough to do that subtraction, so I've got to borrow. And just like what we did over on the left, we go to the middle and there's nothing to borrow, so we've got to go all the way over to the end. So at long last, I can borrow. The 4 becomes a 3. Okay, no problem there. So I have borrowed a full group of what? 6. So the 0 in the middle becomes a 6. But I'm borrowing from that. So now I'm gonna cross that out, and that 6 is now going to become a what? Okay, a 5. If you can write that down in fewer steps than I am, that's fine. I'm just trying to write them all so that you can see exactly what's happened. And so again, I've borrowed a full group of 6. So now at long last, the 2 who had the original problem, the 2 becomes a what? 8. Full group of 6. So here we go now. 8 minus 5, that's 3. 5 minus 3 in the middle, that's 2. And 3 minus 2 is 1. So we get 1, 2, 3, base 6. Just a couple more, just because I want to make sure that we do enough examples, because I know that this is a whole new way. You're basically training your brain to think in a new way. That's what you're doing. And I just want to make sure we cover it well. So do exercise 5 right below. So we're subtracting base 5 in exercise 5. So here we go, 4 minus 1, that works out. That's 3 right there in my units. 1 minus 2, I have to borrow, so I go to its neighbor. This 2 becomes a 1. I borrowed a full group of 5, so the 1 that I'm trying to subtract, what does it become? It becomes 6. 6 minus 2 is 4. That's great. We've got to go through the whole cycle again because now 1 minus 4 here in my second to last column, I again can't do. So the 3 here on the end becomes a 2. My full group of 5 means that 1 there becomes a 6. So 6 minus 4 is 2, and then my front 2 minus 2 is 0. We don't write a 0 when it's the leading number, and so that's just 2, 4, 3, base 5. You don't get where I'm getting the what? Which numbers on the top? The ones that I'm writing in there? Okay. Okay, I crossed out the 3 and changed it to a 2. Okay, so then because of the base of this problem, I've borrowed a full group of what from this column right here? Okay, well, see this right here on the end, this little subscript tells me what base the problem is. So this is base 5. And what that means is each place value is 5 times the previous one. Okay, so everything here is in groups of 5, unlike our numbers, which are groups of 10. So when I crossed out the 3 and it became a 2, I'm now borrowing a full group of 5 objects. And so then I go over here, and that's why this 1 here became a 6, is I took that full group of 5 I just borrowed from the neighbor, and 1 plus 5 became 6. So in the previous problem up here, the green one, this is base 6. So it means each column, each place value is 6 times the previous one. So when I borrowed from the 3, or excuse me, when I borrowed this 4 became a 3, I now had a full group of 6 objects because it's base 6. And so that's why this 0 originally became a 6, which I then borrowed from, and it became a 5. Over here on this one, this is another base 5 problem. I needed to do the 2 minus 4 right here on the end. So what I did is I borrowed from the 3 and it became a 2, and I had a full group of 5. And so that 2, when I take that full group of 5 and move it over, that 2 became a 7. And that's why I was able to subtract. 7 minus 4 is 3. So here's what I'm going to do. I'm going to let everybody get started. Exercise 6. Go ahead and do that. And I'm going to come over and we're going to talk through this one right here. That's base 12. So that means this 7 is not. All right, so here goes on this problem right here. The units column, I've got A minus 8. A, remember, that's 10. So 10 minus 8, that units is 2. The next column, I have 7 minus B. I can't do that. I don't have enough to do that subtraction, so I've got to borrow. So the 9 becomes an 8. I've got a full group of 12 now, and so when I add that full group of 12 here in the middle, that middle becomes what? 19, thank you. Yes, sometimes you just got to wait it out. So then 19 minus B, that's 19 minus 11, that becomes 8. And then 8 minus 4 is 4. So I have 4, 8, 2, base 12. The whole trick, it's not really a trick, but the whole thing you got to be very intentional about thinking is remembering I'm operating in different bases. So my columns represent different groups rather than base 10, which is what you're used to doing arithmetic in. Okay, so we've done adding, we've done subtracting. Now we're going to turn our attention to multiplication. Multiplication, I don't think is, if you understand how to add, multiplication is not too bad. So here we go. I'm going to do the first one. I've got 1 3 base 5 times 3 base 5. So here we go. 3 times 3. What do you get when you multiply 3 times 3? 9. So again, I'm going to come over to my scratch work. I've got 9. Okay, so 9 right there. And my 9, if I'm in base 5, how many full groups of 5 can I get out of that? 1 full group of 5, and then I have 4 left over. Okay, so what I do is just like multiplication base 10, I'm going to say that 1 full group of 5, I'm carrying that 1. And then I have 4 left over, so I leave the 4 down at the bottom. And now when I multiply here, I take the 3 times 1. What's the 3 times 1? What do you get there? 3. And then what do I do with this 1 that I've carried over? You add it to it. Yeah, so 3 times 1 is 3, plus 1 is 4. 4 is not a full group of 5, so it's just going to be a 4. So 4, 4, base 5 is the answer there. So do exercise 7. It's base 7. See how it goes. So in my units column, 5 times 4, what would we call 5 times 4? Okay, 20. So I'm in base 7. So how many full groups of 7 is 20? 2. 2 times, what is 2 times 7? And what does that leave me as my remainder? 6. So it's 2 full groups of 7 and 6 left over. So the 2 full groups of 7, I'm going to carry a 2. And then the 6 left over, I'm going to put a 6 down there in my units. And then we do the whole thing again. 5 times 2 is 10. Plus 2, that becomes what we know as 12. Okay, so you just got to break that habit to want to write down the 1, 2 right here, because you've got to first convert it to base 7. So 12 is 1 full group of 7 plus 5 left over. So 1 full group of 7 and 5 left over. And there is my answer, base 7. Well, the only other thing about multiplication is just remembering like what happens when the number that you're multiplying by is not one digit, like the first two that we did. So I'm going to do the next one, 4 3 base 7 times 2 5 base 7. So let's go ahead and do this. So it's just more fun. You just get to have even more fun. Just don't forget, everything we do in this problem is base 7. So here we go. 5 times 3 is 15. So I'm going to go over to the side. I'm going to say 15. 15 is 2 full groups of 7 and 1 left over. So I'm going to carry the 2 full groups of 7 and 1 left over. I'm going to put a 1 there. Then 5 times 4 is 20 plus 2 is 22. 22 is how many full groups of 7 can I put into 22? 3. 3 full groups of 7 and 1 left over. So since there's no other columns, that's 3 full groups of 7 and 1 left over. So we have 3 1 1. Now I'm moving over. I'm going to start multiplying by the 2. What do I have to remember to do with my answer? What my elementary school teacher and apparently yours did is said, hey, just so that we don't forget where we're supposed to be writing our answer, I'm going to write a little 0 here because we're indenting. And all that means is since I'm now in the second column of my place value with this 2, I'm going to start writing my answer in the second column of the place value. So here we go. 2 times 3, that is 6. 6 is not a full group of 7, so I'm just going to write a 6 right there. 2 times 4 is 8. When I come over here to the side, if you need to, 8 is 1 full group of 7 and 1 left over. So 1 full group of 7 and 1 left over. And what do I do with these numbers now that I've done both the multiplication? You add them up. Here's the thing though, don't forget. You're adding in base 7. To be honest with you, on this test coming up, that's the most common mistake. Okay, most students, once you've done a few of these, it kind of clicks, but I understand how it's easy to lose focus and forget that you're doing this base 7. So don't forget, you're adding in base 7. So 1 plus 0 is 1, no matter what base you're in. 1 plus 6 is 7. Well, 7 is 1 full group of 7 and 0 left over. So I'm going to carry the 1 full group of 7, and then I've got 0 left over, so I put a 0 down there. 1 and 3 is 4, plus 1 is 5, and then I've got 1. So it's 1 5 0 1 base 7. All right, so I'm going to give you a couple minutes. Exercise 8. Go ahead and multiply those two numbers. If you need anything, wave your hand. I will come to you and try to help with any sort of difficulties there are. All right, let's see how it's going. So starting off, I've got my 4 times 2. 4 times 2 is what I would know is 8. We are in base 6. So how many full groups of 6 can I get out of 8 objects? I can get 1 full group of 6, and then that leaves me 2 left over. Then 2 times 3 is 6, plus 1 is 7. So 7 is 1 full group of 6 and 1 left over. And then my final one, 2 times 2 is 4, plus 1 is 5. That is not a full group of 6. So 5, 1, 2 is my first line. We doing okay so far? So once again, whether you choose to write the 0 or not, I have to indent. So since I'm sometimes scatterbrained, I like to write the 0 there to help me remember to indent. So here we go. 5 times 4 is 20. How many full groups of 6 is 20? Yeah, it's 3 full groups of 6, and then there's 2 left over. So I'm going to just kind of scribble these out. So it's 3 full groups of 6 and 2 left over. 5 times 3 is 15, plus that other 3 is 18. 18 is 3 full groups of 6 and 0 left over. So 3 full groups of 6, I carry the 3, and 0 left over. And then finally, 5 times 2 is 10, plus 1 is 13, and 13 is 2 full groups of 6 and 1 left over. Now I'm adding up. I'm still adding. This problem is still in base 6. I don't think it matters on this particular addition, but it's still base 6. So 2 plus 0 is 2. 1 plus 2 is 3. 5 plus 0 is 5. A 1 and a 2. So we get 2, 1, 5, 3, 2, base 6. If there's a question, comment, or concern, please bring it to my attention. We got one more multiplication problem. It's base 2. The fun thing about base 2 is you're multiplying by 1 all the time. So give it a try. And I will just let you know, don't forget when you do your adding, you're adding in base 2. Okay, that's the key thing to remember there. All right, so the nice thing about 1 times anything is just that thing. So here we go. 1 times 0 is 0. 1 times 1 is 1. 1 times the next one is 1. 1 times 0 is 0. 1 times 1 is 1. So there we go. We get 1, 0, 1, 1, 0. I'm going to indent. So I'm going to write a little 0 here for indenting, and now I'm going to go through the whole process again. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0, and then 1 times 1 is 1. So you get 1, 0, 1, 1, 0 again with the extra 0 because we indented. And now we do the same thing again. Now we're in the third place value, so I'm going to indent twice. So I'm going to put 2 zeros at the end of this number now to represent my indenting. And I go through the whole thing again. So 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. And 1 times 1 is 1. So again, I get the 1, 0, 1, 1, 0. And then this time there were 2 extra zeros at the end of it to represent my indenting. Okay. So the nice thing about base 2 is you're always multiplying by a 1. So that's great. The thing just to be careful of, again, is when you're doing this addition, you're in base 2. So here we go. My first column, my units, is all zeros. So that is 0. Great. So far, so good. The next one is 1 plus 0 plus 0. So that's just 1. Again, not too big of a deal. The next one, 1 plus 1 is 2. Okay, so again, if you need to write this down, that's fine. If you can do it without, that's fine too. So if I have 2, how many full groups of 2 is that? Well, that's 1 full group of 2. And 0 left over. So I'm going to take the 1 full group of 2, I'm going to carry the 1, and then the 0 left over. The next column is 1 plus 1 plus 1, that's 3. Well, 3 is 1 full group of 2 and 1 left over. So I'm going to carry the 1 full group of 2, and I have 1 left over. 1 plus 1 plus 1 again is 3. We just saw that's 1 full group of 2 and 1 left over. 1 plus 1 is 2. That's 1 full group of 2 and 0 left over. And last but not least, 1 plus 1 is 2. That's 1 full group of 2 and 0 left over. So we get 1, 0, 0, 1, 1, 0, 1, 0. And the amazing thing is that's how your computer thinks, because computers are binary. They think in ones and zeros. So, and they can do a lot faster than we can. Okay, we doing okay? Remember, practice, practice, practice. Practice makes perfect. That way, when you get on the test, I'm asking you to do these exact same things. It won't be as big of a deal, hopefully, as it might be. All right, so the last thing to do is division. So for division, we are going to only focus on dividing by a single digit number, because division is kind of where it gets just a touch more complicated. So I've done this class many years. I've taught division a couple different ways. So I'm going to show you the easiest way to do it instead of the hardest way to do it. Okay, so that's my promise to you. So we're going to divide in other bases. So here's my example 7. We are going to take 143 base 5 and we're going to divide it by 2 base 5. Notice the exercise I have you do is going to be dividing by 2 base 5, because we're going to take advantage of using some of the busy work. Here is the quickest and cleanest way to do division, because remember, the reverse process of division is multiplication. So here's what I'm going to do. I am going to do my multiplication for 2 base 5. So this is my multiplication table for 2 base 5. Now this is going into the way back machine when we first started talking about place value and things like that. If I am in base 5, I need 5 digits. What are those 5 digits that I have in base 5? What's the smallest digit? Always 0. And so it's 0, 1, 2, up to 4. 0 through 4 are the 5 digits. Okay, so what I'm going to do is I'm going to take 2 base 5 and I multiply by 0. I'm going to take 2 base 5, multiply by 1. I'm going to take 2 base 5, multiply by 2. 2 base 5, multiply by 3. And finally, 2 base 5, multiply by 4. Once you've done this work, this is the hard work to doing the division problem, is coming up with all the values that you could possibly use. So 2 times 0, well, it doesn't matter what base you're in, 2 times 0 is always going to be 0. Remember, we're doing this multiplication in base 5. 2 times 1 is 2. 2 times 2 is 4. 2 times 3, that is 6, but I got to represent that in base 5, so that is 1 full group of 5 and 1 left over. And finally, 2 times 4 is 8. 8 is 1 full group of 5 and 3 left over. Okay, those are all the possible things that can happen when I am multiplying by 2 in base 5. All right, so I'm going to come over here. I'm taking 143 base 5 divided by 2 base 5. So I'm going to write that out. So I'm going to take my 2 base 5 and 143 base 5. Again, we're thinking back to middle school or late elementary school. You had some very nice teacher, hopefully, that was trying to teach you how to do this. So you take the 2 and you say, okay, does the 2 go into the 1? No. Well, you go back, okay, does the 2 go into the 1, 4, the 14? And the answer is going to be yes. So now I come over here. What's the closest I can get to 1, 4 when I'm multiplying by 2? What was that? Yeah, the 1, 3 down here. 2 times the 4 will give me 1, 3. So I'm going to put a 4 right there above the 4 in 1, 4. So 4 times 2, that's 8, and we wrote that as 1 and 3. So now we subtract. And so I'm subtracting in base 5, and so 4 minus 3 is 1. The 1 minus 1 is 0. And now what do I do? What's the next thing I do in this process? You bring down the next digit. So I'm going to bring down the 3. And then you just go through the whole thing again. What's the closest I can get to 1, 3? Well, we can hit it spot on. Yeah, 1, 3. So again, I'm put another 4 up here. 4 times 2 is 8. Represented in base 5, that's 1, 3. And when I do my subtraction, I have a remainder of 0. Great. So what is 143 base 5 divided by 2 base 5? That is equal to 44 base 5. No remainder. Okay, so as I said, you're going to do the next problem. You're going to use this same multiplication table because you're dividing by the same thing, 2 base 5. Because this first one, I wanted you to just be able to do the division. So give that a try. See how you do. 1, 2, 4, 1 base 5 divided by 2 base 5. All right, when I'm dividing, what's the closest I can get to 12 on my base, my 2 base 5 multiplication table? Yeah, we can get 11, so that's 3. So I'm going to put a 3 right above. Remember, the key thing to division, you got to take care of every place. So write that 3 right over what you're dividing into, which is the 2, the 1, 2, the 12. Okay, that way, if there's ever a time when it rolls around that you can't, and you got to put a 0 there, you remember that. Okay, so 3 times 2 is 6, and we represented that up in our multiplication tables by a 1, 1. And I'm subtracting base 5, 2 minus 1 is 1. I'm going to bring down the 4 next. Okay, so what's the closest I can get to 1, 4? That is 13. So I'm going to put a 4 here above the 4. 4 times 2 is 8, represented in base 5. That's one full group of 5 and 3 left over. Again, I'm subtracting, and now I'll bring down that other one. And what's the closest I can get to that? Well, we see we can hit the nail right on the head there with a 3. So 3 times 2 is 6. That's 1, 1, leaves me 0 remainder. So what is 1, 2, 4? 1 base 5 divided by 2 base 5, that is 3, 4, 3 base 5. So exercise 11, I've changed the number just a little bit. So here's what I would like you to do. We're going to do this in 2 steps. Step number 1 is I want you to write down the multiplication table for 3 base 5. So you're going to take the number 3 and you're going to multiply it by the same 5 digits that we did up here with the 2 base 5. Okay, and represent your number in base 5 lingo. So here we go. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. Okay, so now we're representing things in base 5. So 3 times 2 is 6. So that's one full group of 5 and 1 left over. 3 times 3 is 9. 9 is one full group of 5 and 4 left over. And then 3 times 4 is 12. 12 is two full groups of 5 and 2 left over. Whew, couldn't do that for some reason. Guess it's Monday. All right, so here we go. Now that you've got that multiplication table, I'm going to give you another minute or so and go ahead and get working on the division. 134 base 5 divided by 3 base 5. All right, so the closest I can get to 1, 3, or 13 is 3 times 2 is 11. So I'm going to put a 2 here. So 2 times 3 is 6, represented in base 5. That's 11. I'm subtracting base 5. 3 minus 1 is 2. I'm going to bring down the 4, and we're going to go through the whole thing again. The closest I can get to 24 is 22 right here. So 3 times 4. 4 times 3 is 12. That's two full groups of 5 and 2 left over. And when I subtract this time, for the first time, we end up with a remainder. Okay, so we're going to represent this just like you probably did the first time you learned about division. What is 134 base 5 divided by 3 base 5? Well, that is going to be equal to 2, 4 base 5, and then I'm going to write an R for remainder, 2. Okay, we're not using any sort of decimal point or anything like that. We're not going to be advanced enough to represent things fractionally in this class. All right, one more problem. Again, let's do it in 2 phases. What I would like you to do first is write out the multiplication table for 5 base 6. So you're going to have to multiply 5 times the 6 digits for base 6. Right, the 6 digits for base 6 are 0 through 5. So we're doing this base 6. So 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 10 is going to be 1 full group of 6 and 4 left over. 5 times 3 is 15. 15 is going to be 2 full groups of 6 and 3 left over. 5 times 4 is 20. 20 is going to be 3 full groups of 6 and 2 left over. And 5 times 5 is 25, and 25 is going to be 4 full groups of 6 and 1 left over. So there is my multiplication table that I'm going to use and you're going to use. So I'm going to give you another 2 minutes or so. Go ahead and do that division. That's going to be the last problem for the day. And then before you go, I'll just have a couple parting comments about the next week of class. And just one bit of advice, when you're doing your subtracting, you are doing it base 6 if you have to end up borrowing for any reason. All right, just for time's sake, so that you're out of here on time. 5 goes into 34. Well, 5 times 4 is 32. So I'm going to take my 4. 5 times 4. Well, we know that as 20, but then that's 3 full groups of 6 and 2 left over. I do my subtraction. 4 minus 2 is 2. Bring down the 1. Okay, the closest I can get to 21 is 1, 4, 14. So multiply by 2. 2 times 5 is 10. That is 1 full group of 6 and 4 left over. Here's where you got to be super careful. I'm subtracting base 6. So when I go to borrow, this 2 becomes a 1, and I've borrowed a full group of 6. So that means that 1 right there becomes a 7. Yes, said with enthusiasm. So 7 minus 4 is 3. I'm now going to bring down the 0. And we're just about done with the problem. The closest I can get to that is 5 times 3 is 2, 3. So 5 times 3 is 15. That is 2 full groups of 6 and 3 left over. One more time, please remember you're subtracting base 6. So when I borrow from the 3 and it becomes a 2, I've borrowed a full group of 6, so that 0 becomes a 6. And 6 minus 3 is 3. So 3, 4, 1, 0 base 6 divided by 5 base 6 goes 4, 2, 3 base 6 with a remainder of 3 units.